Okay, so lesson 2.3. Just listen to me for a minute. You don't have to write anything down. So in class, we all looked at an example where I had you plot 2 points in the coordinate plane, and I asked you to find the distance between those 2 points. And what we did, we created the slope triangle. Okay, we found the change in the y values. We determined the change in the x values. We saw that this slope triangle created the legs of a right triangle. And then we said, okay, well, we know to find a missing side length in a right triangle, we can use the Pythagorean theorem. Now, we knew what delta y and delta x were, so we plugged our numbers in. And what was our last step? We took the square root of the entire right-hand side. So the distance, the length of that segment, became the square root of these values from our slope triangle. Okay, this is going to become very important. So that was nice and easy. So when you have coordinates, you can plot them, you can draw a slope triangle. Well, what if I asked you, though, to find the distance between, let's say, negative 201, negative 100, and the point 25, 190. Well, if you have coordinates that large, it doesn't make sense for you to be able to plot them on the xy plane. So we need another strategy to be able to find the distance if we know the 2 points that represent the endpoints of the segment. So that's what we do in this lesson. Okay, I'm going to go right to page 2. The distance formula. In order to find the distance between 2 points on a coordinate plane, you could use the distance formula. So we have 2 points. We have an x value and a y value. So now check this out. This is exactly what I just wrote on the previous slide. Here are the 2 endpoints. What is this? That was delta y from our slope triangle. What's this length? This is delta x. Okay, so what does delta mean? Delta means change. So look at the distance formula. To find delta x, I just have to subtract the x coordinates of my point. Then delta y, how do I get the change in y? I subtract my y coordinates of the points. Now if we think about the Pythagorean theorem, the back work here would be hypotenuse squared is delta x quantity squared plus delta y quantity squared. So that's where my exponents come from, okay? So I need the squareds in there. And then how do I get d alone? We always, as a last step, take the square root. All right, so let's use the distance formula for example 3. So I have x comma y, x comma y. So if you want, we can do a little bit of side work. Delta x, change in x values, negative 4 minus negative 9. Okay, that gives me a positive 5. Delta y, the change in my y values, 7 minus 0. So that gives me 7. So if I think about my distance formula in terms of the slope triangle, then my distance would be the square root of delta x quantity squared plus delta y quantity squared. Okay, plugging this into a calculator, and I get 25 plus 49. So I get the square root of 74. And that would give me, and I know it says nearest thousandth, but we'll round it to the nearest tenth. So the distance between those 2 points, 8.6 units. Okay, so for part B, change in my x values, 8 minus 0, that's a difference of 8. Change in my y values, 2 minus negative 4, that's a difference of 6 units. So my distance formula, the square root of delta x squared plus delta y squared. 64 plus 36 would give me the square root of 100, so the distance between those coordinates is 10 units. Okay, C. Example 4, same directions. So let's do A together. Changing my x values. Now I've been taking, if we look at the formula, technically it says x2 minus x1. The order in which you subtract does not matter. And it does not matter because even if we're going to get a negative value, you have to square that number anyway. So change in x. 2 minus 5 gives me a difference of -3. Change in my y values. 0 minus 2. That also gives me a negative difference. But when I go and I plug that into my distance formula, I have to take that change in x and square it, and then I have to take that change in y and square it. So no matter if the difference is negative, when we square it, it'll still become positive. Okay, so I get square root of 9 plus 4, and the square root of 13 to the nearest tenth, 3.6. All right. Part B, delta x. Changing my x values, 4 minus 6 gives me -2. Changing my y values, 7 minus 4 gives me +3. So now here we have a difference where one's negative, one's positive. Does not matter. Delta x squared plus delta y squared, and it ends up being the same, it'll be the same distance as part A. Because I get the square root of 4 plus 9, and we just showed that that was equal to 8.6. Okay, so we'll complete example 4 in class, but I do want you for homework to complete example 5. And then you do not have to move further in the packet.